right, so project 3. Has anybody actually started on it? Yes? No? A few people? That's good. That's good. It's really important to get started on that and kind of get it underway. We're going to go over task 0, kind of just general project stuff, and then task 0, which we didn't do, right? I don't think I did that with you guys last week. I started doing it on Monday. Yeah, that would make sense. It came out on Monday. So we'll go over task 0 and then go over some first sets and then go over task 1, which is implementing first sets. I felt like that was a good order to go through. This is just a basic overview. It reads in, the whole goal of this is to read in a CFG and it'll turn it in, or you're able to get it in as tokens, and then you're gonna create your first and follow sets from those tokens. You can use the previous get token. You have to be careful using it. I was able to modify it pretty quick just the other day, just kind of playing with it to see how difficult it was. But it was built for the regular expression from part 2 of project 2. But it's just nice, the space skipping, all that stuff's already built in. It's already reading from standard in. If you can kind of get it tweaked to what you need, it'll save you a little bit of hassle.
So what sort of things should we tweak? I think it's just the language, or takes in characters instead of the statements, and setting up a variable for the arrow.
The arrow, the hash, the double hash, all those, yeah. ID should already be there, which is nice. And I think it conforms to the same rules, which is nice. And that'll at least help you kind of build your tokens. So we have in the project description a grammar description of something that describes grammars. This is what the input into your program must look like. This is the grammar that the input into your program must follow, or is supposed to follow. Digits, letters, A through Z, upper and lower case. An ID is a letter with optionally any number of letter or digits following that letter, just like in a C ID or a variable. Hash is just a single pound sign or hash depending on your age. Double hash is 2 of them, and then an arrow is a dash and a greater than sign. All the tokens in the file are space separated, so you can use that as a delimiter. And when you hit a space, you know you're on to the next token. Here's just the overall description for the project. The first line, basically, the first line is a non-terminal list, which is made up of an ID list, and then it ends in a hash. So you see it here, this is non-terminal, 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 ends in a hash. And then the ID list is an ID, which is the letter plus any number of letter or digits, concatenated with the ID list coming back to itself, and or just a single ID. So there could be just one here, but there's no epsilon or anything here, so there's going to be something there typically. And then if not, it's an error, be an error condition. So after the non-terminal list, we go to the rule list. This is the rule list right here. It starts with an ID. Notice how it's generic, so it's reusing ID here again. And then arrow, which is this guy, and then the right-hand side, which is defined down here, it's just an ID list again, but it can have an epsilon. So this is an example of that, where it just ends in the hashtag, so it's ID, arrow, right-hand side, hash, the right-hand side is epsilon in that case. Any questions?
So if you put a hash and then the ID, would that throw any errors, or would you have to account for that?
If you put a hash and then the ID,
yeah, would you have to check for that as well?
What would be wrong with that? So I have an example in a second, but I'll go ahead and say it. This is all pretty and on separate lines, which is great. but it's not required. New line, or next line, line ending characters are not described in this grammar. What ends a line in the grammar is the hashtag. So yeah, you could have a hashtag followed by an ID right here, all on the same line. I have an example of that in a few, but that's totally valid. It doesn't care about new line characters. It doesn't look at them, doesn't evaluate them, anything. So what are, in this one, so this is sample input, what are the non-terminals here? It's not actually a trick question. What? Yes, exactly. NT1 and 2 and 3. All right, what are the terminals? Yeah. Amp, pipe, semicolon, and ID. Yeah, exactly. Amp, pipe, ID, semicolon. So those are, we've got the non-terminals and the terminals. Here's crazy style. So this is what I was talking about a minute ago. This is completely valid. The delimiter is the hash. So you can have a hash and then an ID after it, which is your question. That's totally fine. Actually, this is not, it's actually not valid grammar. This is not valid. I should have another hash right here to end the line. So a hash to end the line and then a double hash to serve as end of file there. It should have that. Because if we go back to the definition, every rule has an ID arrow right-hand side, which is number 0 or more, but it has to end in a hash. And then coming back up at the end of rule list, it has to end in a double hash. So this line is actually not valid. It should have a hash there. All the bugs. So for this one, the way they're breaking up the task is by what's passed in as arguments. So for task 0, you pass in a 0 argument, and that'll start this part of the code. I think they give, you've got a starting C program that's already got a case statement built in there, grabbing the parameter so that you can break your code up, hopefully into separate, at least functions to do that. So the output from task 0 is the first line is all the non-terminals. So it's actually real similar to just this line here. You could just, you can output almost the same thing, except the non-terminals are listed in the order encountered. So, for example, if these rules had been in different order, I actually followed it when I created this NT1, NT2, NT3. So you would still list them in the same order, but if NT2 had been listed up here, then it would have to come first on the list on this output. Yeah, so after the last non-terminal, when you're done, instead of a hash, your output ends with just a new line character. Just makes it go to the next line. And then for the remaining lines, you're creating a line for each unique terminal. So each terminal that you have, you start with the terminal followed by a colon, a space, then an integer, which is the number of rules in which the terminal appears on the right side, and then a new line. So here's an example of some input, again with a bug in it, such a bummer. And then some sample output. You've got the NT1, 2, and 3, amp is 3. So that's not a bug. We have, the rule here is that you have an amp, you have the count be for how many times it appears in the rule. Multiple times don't count. So you only count once per rule. And even though these two non-terminals are the same, we count them as separate rules. So even when you look at it with the shorthand, and I didn't know this before Tuesday, but Even when you have the shorthand with the bar separating them, they are considered separate rules. So each line is considered its own rule, even though it's got the same non-terminal. And so that's where we come up with 3. Even though you only count that as 1, you count that as 1, that as 1, you end up with 3, and the rest with 1. Any questions?
So it's only the non-terminals, right?
What's that?
It's only the non-terminals?
It's none of the non-terminals?
No, it says it's only the non-terminals that are printed out.
That are where?
Sorry, for the output, it's supposed to output all the non-terminals. It's supposed to output the terminals in the beginning, then all the times the non-terminals.
Well, these are the non-terminals, right? These are all the ones on the left-hand side.
Okay.
Which you can actually get from the first line of the file if you want.
Okay, sorry, I got that confused. I thought the first line was the terminals.
No, first line is the non-terminals, which is really nice that he does that. He doesn't make you guys parse through the file, figure out what they are, and then do it. You get them all up there. The problem with this part is that they are ordered. They are to be printed out in the order that they're encountered. So it may not actually help you that much. That's from the requirements. So in this one, we have a double hash here instead of at the end, and at the end. But as soon as your program encounters the double hash, it thinks it's the end of file, it's done. So the output for this, if there was something like this on the server, would be nt1, nt2, nt3, and then amp1. And this is why, well, part of the reason why you're getting it from up there. So for working through Project 3, for those that haven't gotten started, even on Task 0, come up with something that works. Whether it's brute force, it's ugly, you think it's a gross way to do it, but you think it'll work. If that's conceptually how you can think through the problem, then just get it working. Just get that part working, and then come back to it and refactor it. Come back. You're passing the test cases. You've got this code. You can even copy your old code to a different function just to be safe in case you mess something up, and then take that code and make it better. Figure out ways that it'll work better with the later tasks. But the first goal is just to get rolling. Get something out there that is easier for you to understand and parse, and then you can worry about refining it. We're not going to look at your code for this, meaning when you turn it in, it's all about the test cases. For the given input, does your output from your program match what the computer is expecting? So it needs to be precise and exactly what it's expecting in order to pass the test cases, just like for the test cases that we give you. So what are some data structures that might work for this? What would be one way to do it, or an idea?
Just a linked list.
What's that? A vector would be a good idea, or a linked list. And then, so you have a linked list. Of course. You have a linked list, or vector for that matter, that kind of looks like that, right? So these would kind of represent what? Yeah, your non-terminals? Yeah, so you have, this is NT1, NT2, NT3. And then where would your terminals go? Inside of them? Yeah, exactly. So we could draw it like this maybe. You could even make it, that kind of represents an array. You could do it like an array, I'm certain there are no non-terminals that have over 100, for example. You could do it that way, just a brute force, kind of your brute force. Not the most elegant way to do it. Would probably work. You just had an array here to 100. But is there another way that's not too bad either that you might do it?
Couldn't you just add a vector inside of that vector?
Exactly.
Or a linked list inside of linked list, whatever one.
Yeah, whatever. Whichever one. So you can use the standard libraries. So you can use whatever you want. There's already a linked list, there's already a vector, hash map, all that stuff is already there for you. You can use it. Great examples on Stack Overflow. But yeah, so you could build vector / list in here, and these would be like, whatever, amp or whatever they are. That'll work pretty well for task 0. For task 1, I think you'll run into a slight problem with it, but it'll get you going for task 0. We can talk about that a little bit more on task 1. But for task 0, I think that'll pretty much do what, well, I don't know. Does anybody see an issue with that? What an issue might be? Let's say you had a rule. You've got A, B, yeah, or A. And A is going to be A dot or C, I don't know. B is B, whatever. So you could put this would be the S, right here, and then S is going to have some kind of. This is going to be, represent your AB, and then A, and then nothing below it. But one of the problems, we've got 2 characters here, right? Got 2 tokens there. How are we going to represent those? How are we going to, you could just use a string, I guess. Any other ways? Nothing? Everybody's quiet. Is it too early? It's like, I've been up for 4 hours. All right. You have a picture of it, at least, to start thinking through it and to think about what you might want to do. Good. All right. So, come up with simplest solution first. Thinking through what would be the simplest way to do it. If it seems complicated in your head, if you're trying to keep all this in your head while you're programming it, just write it down. Just draw a picture. Draw this picture. Draw something similar. It'll make it so much easier to code. Our short-term memory stinks. We can't remember that much at a time. And if you can't chunk it up, if you can't make it into things that you can kind of process all at once, we need some kind of reference. That's why, slides, we put the slides up there so that you can kind of see it too and refer back to it. Just draw a picture of it, and that'll help you while you're coding to kind of break the problem down into what you need to do it. And break it down into little pieces and make that piece work and then move on. Test it. Go ahead and test it. Write some lines of code. Does it do what you're expecting it to do? Yes, then move on. That's a good way to make sure that you're just building on stuff that already works instead of outputting 60 lines of code and then trying to figure out what one line in there is, got a double equals instead of an equals or whatever. So we're studying first sets. I'm not completely through his lecture from, yesterday, but the short of it is we're wanting to be able to efficiently parse the tokens into a parse tree. And we want to be able to be looking at a specific token and know where we're going from there based on the one token. So it gives us the capability basically to make decisions based off of a single token by looking at the first sets. Well, by using first sets to figure this out, by seeing if there's overlap between first sets that could appear in the same non-terminal, same production rule, or set of production rules. All right. So this is pretty similar to his slides. I had a horrible time with his slides, and I should have probably told him this. When he used X and Y here, or X and B, I think, or no, A and B. He used A and B. And then all the examples have A and B in them. And I got so confused between what was the rule, what was A, what was B. So I'm shifting it up a little bit. I added some color coding too to kind of give you an idea. But the non-terminal, the N for non-terminal, is going to be is in purple here. So we're looking at whether adding basically whatever this Y is and minus the epsilon. So you add that, you were adding that to the first N. This says, this is the rule from his slides, just with those substituted and the colors added. So rule 4 is, I did kind of the same thing, and then rule 5. So So looking at rule 3, this is how I would say it, or try to say it in English. All we're looking for is the leftmost character, the leftmost symbol. So the Y in this case, that's the most to the left. Symbol. So it could be a non-terminal, it could be a terminal. We're looking for the leftmost symbol. And we're taking the first of whatever that symbol is, minus epsilon, and adding it to the first of N. So that's how we're building up N's first set. Does that make sense? Kinda, some nods. No shake heads. That's good. All right. So for rule number 4, the way I think about it English-wise, and I've refined this probably like 6 times since I started working on the slides, but if all the non-terminals before I plus 1 have an epsilon in their set, then we add that particular one to the first of N. So basically, if it's possible that everything that comes before, if we had A, B, and C up here, and everything that came before, if all of those could be epsilons, then we also need to add the first of C, right? That's what the rule's saying. For the last one. The last one's kind of like a special case of number 4. It's for when all of these, when all of those are epsilon, so they could all be blank, then in the first set of S, we include epsilon, right? So they're all epsilon, they have all epsilon in them, then that's when we finally add epsilon to S, because it's possible for all of them to be epsilon, and that transfers to S. So N's inheritance is the way I kind of shortened it. And so actually when I took the exam, I had something similar to these. These are all I wrote, were just the English rules were easier for me to kind of parse through and get from, I'm not a math person. I'm always struggling with the math a little bit in some of the classes. But so I used the English just because it was easier for me to follow and work through. But you guys can use whatever you want. Any questions? Nothing? All right. So as I said earlier, Y is a symbol. It's not a non-terminal. It's just a symbol. It could be a non-terminal. It could be a terminal. Symbol. Yeah. Alpha. So we have alpha in rule 3. Alpha is just referring to the rest of the line. It could be a bunch of symbols or no symbols. It's basically, we're using the alpha, we're ignoring the rest of the line. So with the Y alpha, we're just ignoring the rest of the line. We don't care about the rest of the line. So we're pretending it's all in alpha. It's not important to us at this point. So when when you look at the rule, part of the rule up here, you've got the alpha here. We just don't care about this part. All we care about for the first set of n for this rule is what's in the first of y. So, as we're going through something on each pass, we look at Rule 3. Rule 3, 4, and 5 are the rules that kind of push us forward, are the rules that work through everything. There's some shorthand that we can use, and Adam did a great job of making this really clear in his office hours yesterday as he was going over one of the problems. But these are the rules that you use every time to push you forward. Okay. So for this example, I'm going to do it through the PowerPoints. We'll see how it goes instead of handwriting it out, just because I have a couple points that I want to make about this problem in particular. But on the next one, I'm going to try to do it on the board. We'll do it as we go. So we always start with all the empty sets. This is the reason we do this is it's just an algorithmic way to start. We're defaulting everything to empty sets. It's just like when you're setting your variables to 0 and you're gonna add them as a counter or something. You want to set it to 0 so you know where it's starting, and then you add 1 to it every time. So on this first one, Rule 3 technically applies. It just doesn't apply to anything. When we look at A is the empty set. Empty set plus empty set would still be an empty set. There's just nothing there. And then that's good. All right. So for the first of A on this line right now, what goes in the first of A? Yeah, epsilon. So we're looking over here for the first of A. We take Rule 3, which is a y, alpha on the end. There's nothing on the end. That's fine. And then we take the first of, what's the first of epsilon? It's just, the set of epsilon, exactly. So we apply Rule 3 and then Rule 2, and we end up with the set of epsilon. No cheating. So what about for the first of B? What do we got? V? V? V is in Victor. Anything else? Okay. Epsilon. Yeah. So we apply Rule 3 again, and we look at this guy. The first of V is the set of V. And then technically we apply Rule 3 again to this rule over here, and the first of epsilon adds the set of epsilon. So we have V is in Victor, epsilon. And for C, looks pretty similar to the next one. Yeah? Yeah.
It would be T epsilon.
T epsilon, exactly. So I've kind of looked at the homework. Your problem was similar to ours that we had last year. It's different, but it was similar. This is pretty close to the way that I printed it out so that I could kind of track everything, and so that I would get, if I made a mistake, would still get partial credit. Pretty sure that applies on this one too. All right. So that's a bummer. Anyways, this is Rule 4. Does Rule 4 apply to the B in S goes to ABC? Because epsilon is?
Yeah, it's epsilon with A and B.
Right. So, what would we add then? What do we add?
So it's not, you have that epsilon's not because of the
Yeah.
case.
So if we're looking at B. A has epsilon in it, so what do we add? What do we add because A has epsilon in it by this rule? What do we add?
Just add the first and epsilon in there, because we don't subtract it, because it's for each one that has epsilon.
Well, yeah, we only.
Or did I get those mixed up?
Yeah, I think you're thinking of rule 5.
Yeah, I think that's.
So for this one, I'm losing it. This one, we look at the first of I plus y, and I think I heard it back there. You add the first of b. First of b to there. So this one is of the form, it looks like this, kind of thinking about it in like this format up here. It looks like it's looking like this, where this is A, B, and C. And then, so I is equal to 1. When we're matching up to this rule, I is here. It's equal to 1. So I plus 1, I'm sorry. It's supposed to be 0. Yeah, sorry. I plus 1 is B, so it's equal to 1. And then the K in this one is 2. And so we end up with adding the first of B, which is equal to B and E up here, B and epsilon. We subtract epsilon from it and add it to the first of S. So that gives us the V, and then you get the cheat again because the slide's not right. So does rule 4 apply to C here? You don't think so? Maybe? Anybody disagree? Could it maybe apply? Nothing?
Yeah, it would still apply. So you would add C, or first C minus epsilon.
Yeah.
Which is.
So in this one, if we go, we're of the form, we look like this right here. And I is actually equal to 1 in this case. I plus 1 is equal to 2, which is this character. K, we don't care about. K is just something that's just letting us know there could be more characters there. We don't have to follow it. So we would add, in this case, the first of I plus 1, which is 2, which is also C. So we add the first of C, which is the T and the E. Minus epsilon, T and epsilon, sorry. So does rule 4 apply to any of the other rules here? Does rule 4 apply again in this case? Does it? I see at least one head shake, that's good. Yeah. It doesn't, because we have no way to set up the I plus 1. The I plus 1 in this one's the most important thing. We have to have a character that corresponds to it. So if we're in this form, and that number's wrong. If I is 2, I plus 1 is 3. There is no 3. So we couldn't add the first of there is no to this, so that means that it doesn't apply. So this just kind of brings about the hidden implication. It's kind of hidden in the code of rule number 4. It must have an I plus 1. We must have some kind of symbol that corresponds to the I plus 1, so that the first, because we need to add the first of I plus 1. And if it's not there, we can't add the first. Everything else, the dot, 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 y to the k, that can all be ignored. Does rule of 5 apply in this case? Yeah, yeah, yeah. Are all of A, B, and C, do they all have epsilon in their first sets? Then it applies. So S can also have epsilon. So we end up with rule 3, 4, and 5 all applying. Did any of these guys change on this round? Yeah, just S. So we'd go through it one more time, nothing would change, then we're done. So we keep going until nothing changes, until none of the first sets change. Any questions? Easy? Not easy. I had a horrible time with first sets and follow sets. That's why I still think it was the hardest programming assignment for me. Adam has gotten way better at teaching it, having listened to his lectures now. It could be that I just know more now, having gone through it once. When you relearn something, it's much easier. But yeah, I struggled with them, so I do not think they're easy. I don't care what people say. But no questions? It's fine to ask questions. I prefer questions.
Do you know what the best way to go about doing the algorithm is?
You mean implementing it in your code?
Well, I mean, just like going through it manually, because I mean, to break it down, it's basically just an algorithm, right?
Right.
So how would the best way to go about it manually be?
I approach it using my shortened abstracted rules is how I tried to do it. I found I had a lot more luck with that than trying to think about Y1, Y2, Y3. I'm just not a computer. Not a very good computer, at least.
Two of us.
So that's why back on the slides at the start, I kind of had the abstracted rules where I said, okay, if they're all this, then we inherit. That kind of stuff helps me. That's how it helped me process through it.
And so for each symbol, do you just go through all the rules? So say you're on S and you start at A, you do that, and then you go to B and then C.
Yeah. So you apply rule 3. Apply rule 3 till it doesn't apply. Well, rule 3 would only apply to the leftmost character. And then rule 4, you would look at until you ran into something that didn't have an empty set in it. Or I'm sorry, that didn't have an epsilon in it. Excuse me. And then for rule 5, same thing. It applies till you find something that doesn't have an epsilon in it. All right, moving on. So, I've got, hopefully it's probably not totally readable to everybody, but I've got the rules up there, and then we've got a new, oh no, that's the one we did. So everybody has to vote. Do we want to go through this? I've got, wow, well that clock's a little off. I've got 7 minutes left. So I can go through this problem. We can work through it, or we can talk about task 1. I don't have time to do both, not within. So who wants me to work through a little bit bigger, longer first set problem? 2 people? All right, 3 people? This better add up, guys. This better add up to the total number you in here. All right, who wants me to go over the part 2 of the or task 1 of the project? Oh, that's going to add up. That's pretty close. All right, so the second group has it. I'll probably work this problem, definitely not at my cube here, but at home, and I can still post the video. So if you want to go back and watch it. As I said, Adam's recitation hours were great, but this one's a little, I don't know if he has one that's a little more involved like this, like your homework is a little bit deeper. So I'll go over this one there. When I did this problem for homework, my homework looked pretty close to this. So the only part that's kind of interesting that I never talked about and Adam never talked about was I brought across the actual rule, production rule side, and then marked through it as I knew it was consumed, as I knew it wasn't going to change, so that I kind of known what it's that working memory, it's the short-term memory, just keeping it in your brain. And so that was my way of going, okay, I've already processed those, I don't need to look at them as I move forward. It was just a trick to try to make sure that I got the problem right, and help me with my poor computing capabilities. So for program 3, task requirements for it are actually, I think, shorter than task 0. But at the end of the day, you're creating first sets. You're taking the algorithm that he's defined in class and gone over repeatedly, and you're implementing it for the input that are in these files. This is a sample line from the output. Notice how you've got the, I can't 100% guarantee that's not supposed to be a fully capitalized first. So just remember that. Write it down in your brain somewhere if you're looking back at this slide, or look at the requirements to be sure. But notice all the spaces that we have here. We've got a space between the equal sign, a space between the brackets, a space after the comma, and then a space before the end of the brackets. So just keep track of the spaces. The line ends with a new line character. So if you take the long example that I kind of showed you the answer to a minute ago, and you put it in, your input would look kind of like this, with the hashtags and then a double hash at the end. It would have the first line as well that I didn't put there. Then your output would look something similar to this. First S equals with all the spaces, and then a new line on a separate line. That's it. That's all you have to do, make that output. It's easy. Not really. All right. Where to start? So you could, at the start of this, kind of refactor 0 to get it into something that's a little more dynamic. That's kind of like the picture we talked about if you didn't do that to begin with. I mean, once again, just kind of start simple and build. I would, where's a good place to start? So what rule would you maybe start with implementing? One or two would be a totally good place to start. You're only worried about one character. You could create a couple really simple inputs with just one character and see if you could parse through. And I would probably just start with one and I wouldn't even worry about epsilon right now. You get points for getting the non-epsilon version working. So I wouldn't even think about epsilon at this point. I would think about a simple problem. Get one working. And then after one, if you're not worried about epsilon, what's the only other rule you're worried about? 3. And then I'd worry about rule 3. And 3 is your for loop. It's going to push you through all the other, it's going to push you through. Well, it's not even going to push you through. It's just going to grab and it's going to be your drill into when you have non-terminals. It's going to, your leftmost character, you're going to expand that and bring the first set from whatever that leftmost character is. But yeah, I would start with rule 1, get that working, test it, make sure it's working, keep that test in there, add my own test. I mean, the script should run any number of tests that you add to that. And then definitely keep adding my own test in there as you go, as you come up with different things. As you come up with bugs, find a test case that exercises the bug, then add it to your test cases so that you're testing it from then on out. Just a bunch of test cases, super helpful. They've got some hidden test cases on the server for this one. That's what took me the longest with this project. I got all the ones working, and then we have hidden ones that are testing some boundary stuff that it's harder to think about. So that's the push on this one, is getting the unknown is getting the hidden test cases on this one. But start simple, get started soon, and get moving on it, because it doesn't sound hard, but it's like the nitpickiness of it is what will get you. And if you get done early, you're a super awesome programmer, then that's great. But everybody in here, overall, we're all average. We may think of ourselves as more than average at all the things, but overall, we're average. And the average person struggles with this and has to get through it. So
Would you say a good place to place probably to be by the end of the weekend is like maybe implementing the lexicon, the parser, and and starting on part 0.
Yeah, I would definitely be done with part 0 by the end of the weekend. My personal opinion. I'm a weirdo. I mean, I would be done with this by the first weekend, just because I can't handle not having problems solved. I can't handle not doing programming assignments. I've been programming since I was, seriously, almost daily since I was a freshman in high school. So, and I've probably, programmed just about every day of my life since then. For fun, not fun, work, whatever. Even when I was in law school, I had all these really cool VB scripts that I'd tweak all the time to run in Word to like auto-highlight stuff for me and do all this different stuff. But I couldn't handle not doing it, so I just dug in and started on it. I didn't finish it the first weekend, but I had the basics of everything working. Like the first weekend, it was the test cases on the server that I was having trouble with. But and I started with, we didn't get this part 0 part, so I started with getting the first rule working, and then got the third rule working, and then ran through all those test cases. But yeah, I would definitely have part 0 done. You've got a month. It sounds like a really long time until you get a project from another class or whatever, but find the bandwidth, put in the time on it. It's hard. There's also a cognitive science thing, which is where my background was kind of prior to this, prior to switching to being on Adam's team and in security, in the security group in SEPFCOM. And when you have a hard problem, stepping away from it is one of the best things you can do. I don't know who's ever solved a problem while in the shower. You've been like stuck on it for however long, and it's really tough. You can't figure out why, and you're in the shower, and you're like, oh, I got it. Your brain keeps chugging on problems, even when you're not looking at the computer screen. Your subconscious is in there just kind of chugging on it, going, how could I work this through? How can I work this through? I've dreamed about problems before. If you're really involved and stuck at a certain spot, that totally happens. For sure. So, little anecdotal thing, Adam's software security class he has for grad students, I took that last semester. That's why I switched to SEPFCOM, actually, and switched into security. But he had this really cool, you went up levels. So you had to break certain things and break the security of it, and then you get to the next level, and it had 15 levels. And level 15 was insane. I just couldn't figure it out. I spent the whole weekend with a highlighter looking at assembler code, trying to figure it out. Come to find out it had been compiled improperly, and it wasn't breakable, actually. So he had to recompile it, and then it was no problem. But I had dreams about that. I just couldn't, just can't let it go. So yeah, I'm a little weird. Probably not the only one, but getting started on it early, get your brain going on it, get you thinking, and getting done with it early is a great feeling. So that's it, guys. I held you over a little bit. Sorry. Any questions? Feel free to come ask me or come by office hours.